Hi students, this is Kiran. Please have some discussion in electricity and magnetism. Of course, physics we are discussing electricity and magnetism. In this electricity and magnetism chapter, module 1. In module 1, we are going to discuss about Coulomb's law. Now, have some discussion of electric field and potential. Before going to that electric field and potential, we need some values of inner atomic particles. Consider inner atomic particles. Yes, charge of electron is 1.602 into 10 power minus 19 coulombs. Please remember it is negative charge. What is charge of electron? Charge of electron is minus 1.602 into 10 power minus 19 coulombs. Please remember Coulomb is the unit of charge. Unit of charge. What is the unit of charge? Coulomb. Of course, the scientist name. Mass of electron. Mass of electron is 9.11 into 10 power minus 31 kgs. What is that? Mass of electron is 9.11 into 10 power minus 31 kgs. Charge of proton. Charge of proton is 1.602 into 10 power minus 19 coulombs. Able to observe that charge of electron and the charge of proton, they both are same in magnitude, but they are opposite in nature. Charge of electron is negative, charge of proton is positive. Mass of proton. Mass of proton is 1.672 into 10 power minus 27 kgs. What is mass of proton? 1.672 into 10 power minus 27 kgs. Charge of neutron. Charge of neutron is 0. Mass of neutron. Mass of neutron is 1.675 into 10 power minus 27 kgs. Please remember, neutron will not have any charge. It's neutral. Mass of neutron is 1.675 into 10 power minus 27 kgs. Now, Coulomb's law. What this Coulomb's law says? This Coulomb's law explains force between any two charged particles. Coulomb's law explains force between any two charged particles. Of course, they are the charged particles. There will be some force because of their charges. But please remember, opposite charges attract, same charges repel. The force is given by F is equals to KQ1 Q2 by R square. Of course, it is given by Coulomb, the scientist Coulomb. The Coulomb's law once again, F is equals to KQ1 Q2 by R square. Please remember it is a formula. Remember it as a formula. Of course, we do prove that, but still, you should remember, you should by heart it as a formula. Force is between two charges here. Where is that force? Between two charges. It may be repulsive, it may be attractive. The force is given by F is equals to K Q1 Q2 by R square. Now, F is force between any two charges. Like charges repel, unlike charges attract. Yes. Able to observe, there are two charges. They are opposite in nature. They are opposite in nature. They do attract. The force is given by Coulomb's law. Similarly, again there are two charges, but They are same in nature. They are same in nature. Both are positive, we consider. If both are of same nature, they do repel. Like charges repel. Unlike charges attract. How much is the repelling force? The same thing, F. Now, in the Coulomb's law, F is equals to K Q1 Q2 by R square. What is K? Proportionality constant. Q1 is charge of first particle. Q2 is charge of second particle. R is the distance between the particles. Yes, that is R. So here R is the distance between the two charges. In the formula, R is the distance between the two charges. Yes, Q1, Q2. Now, let us have some discussion about that F is equals to K Q1 Q2 by R square. How it is formulated. It is a formula, but how it is formulated. Let us observe now. Here, F is directly proportional to Q1, isn't it? F is directly proportional to Q1. What I mean, what Mr. Coulomb observed, F is directly proportional to Q1. F is directly proportional to Q1, isn't it? What I mean to say, consider Q2 as same. Let us increase Q1, force will increase. Let us decrease Q2, force will decrease. What I mean to say, force is directly proportional to Q1. That is first logic. Now similarly, F is directly proportional to Q2. Here, let us make Q1 constant. Q1 constant. Now, increase Q2, F will increase. Decrease Q2, F will decrease. Able to understand? What I mean to say, F is directly proportional to Q2. Now, F is inversely proportional to R square. F is inversely proportional to R square. See here, one should get a doubt. What is that doubt? R is distance between the two particles. If we decrease R, F will increase. If we increase R, F will decrease. Of course, agreed. But why we are taking R square here? Of course, there are so many reasons explained in the society, but the fact is, in general mechanics, if you observe any two particles and the distance between the two particles with respect to a reference frame, if one particle is detached, also means that the other particle is detached. What is that? In general mechanics, in a reference frame, if there are two particles considered and the distance between them is being considered, if a particle is detached, the other particle is also detached obviously. See, for example, there are two friends. If one of them is moving some distance apart, also means that the other person, the other one also detached with the same distance, isn't it? Now, yes, once again, F is directly proportional to Q1, F is directly proportional to Q2, F is inversely proportional to R square. Why R square? You should consider two particles in a reference frame. If one particle is being detached, the other particle also is to be detached. For example, once again, if you are detaching from your friend, also means that your friend also detached from you, isn't it? Now, by clubbing all these three logics, you will be getting F is equals to K Q1 Q2 by R square. K Q1 Q2 by R square, where K is proportionality constant. Where K is proportionality constant. Why this much explanation here? To get the logic of R square inversely proportional to R square, some people, few people, only few people, they do manage the units, they do manage the dimensions. But the fact is, you should apply a reference frame. Now, once again, there is a wrong context in this Coulomb's law. What is that wrong context available in the society? The Coulombic force is same in all mediums. No, it is not same. If you observe the formula, F is equals to K Q1 Q2 by R square. What is K we observed there? The proportionality constant. Just by feeling that that is a proportionality constant, these people will be saying that F is same in all mediums. But it is not true. Here, K has got some other context. Here, K is equals to 1 by 4 pi epsilon naught. K is equals to 1 by 4 pi epsilon naught. Where epsilon naught is permittivity of free space or vacuum. Here, permittivity differs for different mediums, isn't it? When permittivity differs for different mediums, obviously K also will be differing. But please remember, in the same medium, wherever you do experiment, Coulomb's law, Coulombic force is same, but not for different mediums. Now, epsilon naught, the permittivity of free space or vacuum, or we can consider air also. Epsilon naught is equals to 8.85419 into 10 power minus 12 Coulomb square per Newton per meter square. Per Newton per meter square. Similarly, K is equals to 8.98755 into 10 power 9 Newton meter square per Coulomb square. Newton meter square per Coulomb square. Please remember the units. I will make you to learn how to manage the units also. Now, how to manage units. Using F is equals to K Q1 Q2 by R square, we find the unit for K. Using F is equals to K Q1 Q2 by R square, we find the unit for K. Yes, F is equals to K Q1 Q2 by R square. Simply make K alone. K on the other side. Bring all the terms to the other side. Now, K is equals to, rearranging the terms, K is equals to F R square by Q1 Q2. Please rewrite K by using the units. K is equals to force unit is Newton. Do take distance unit is meter. In place of R square, you can take M square. Charge unit is Coulomb. In place of denominator, you can take C and C. So, K unit is Newton meter square per Coulomb square. Now, using K is equals to 1 by 4 pi epsilon naught. Already we know that. What is that? K is equals to 1 by 4 pi epsilon naught. We find unit for epsilon naught. Yes. Here, K is equals to 1 by 4 pi epsilon naught. implies rearranging the terms implies epsilon naught is equals to 1 by 4 pi k. See, in the denominator 4 pi is simply a number. Replace the unit of k where? In the denominator. So unit for epsilon naught is 1 by Newton meter square per Coulomb square. Implies epsilon naught unit is c square. Why it has become c square? Because c power minus 2 in denominator, when it is coming to numerator, it will take c square, the value. Newton whole power minus 1. Why? In the denominator it is. In the denominator n is there. When you are bringing that to numerator, it becomes n power minus 1. Similarly, in the denominator, m square is there. When you bring that m square to the numerator, you will get m power minus 2. Therefore, epsilon naught unit is c square per Newton per meter square. Per Newton per meter square. Now, again, limitations of Coulomb's law. There are some limitations of Coulomb's law. Again, please have some discussion about the limitations of Coulomb's law. Coulomb's law is valid only for static charges. Coulomb's law is valid only for static charges. Why is it so? If the charges moves, what will happen? Between any two charges, when you are discussing about Coulomb's law, if any one of the charge is moving, there is magnetic field arised. Magnetic field comes into picture. Obviously, magnetic forces also comes into picture. Then the net force of attraction or net force of repulsion between the two charges is the summation of electric charges and magnetic forces generated. See once again, when magnetic field comes into picture, there arises magnetic forces also. Then the net force is the summation of Coulombic forces as well as magnetic forces. So here is a big limitation that Coulomb's law is valid only for static charges. If any charges moves, magnetic field comes into picture. Now, the second limitation. Coulomb's law is valid only for point charges, not for distributed charges. What is that? Coulomb's law is valid only for point charges, not for distributed charges. Yes. Discuss about first limitation. There is a charge. There is one more charge, isn't it? Obviously, there will be some force of attraction. Why? Able to see? They are of opposite in nature. Maybe force of attraction or maybe force of repulsion. But Coulomb's law is valid only for static charges. If they move, if any one of them move, if both of them move, whatever be the case, if any one of them moves, magnetic fields comes into picture. Able to watch this? So please remember, when magnetic fields comes into picture, obviously there will be magnetic forces also generated. Then the net force is not just because of Coulomb's law. So Coulomb's law is limitized only for static charges. Now, the second limitation. Second limitation is Coulomb's law is valid only for point charges. Why is it so? If you consider two distributed charges, if you observe in the diagram, if you bring two distributed charges nearer, what will happen? The charges will accumulate at the edges. Here, the distance between the charges is not distance between the centers of that charges. They are distance between the center of the charges. Let us observe in the diagram. In the negative charge, the charge is accumulated at the end because it is a good conductor. The first particle is a good conductor, the second particle is a good conductor, but both the particles are charged. When you bring them nearer, the charges will move to the edge, isn't it? Now, there is center of charge observed. Like in our gravitation chapter, we do be taking always center of mass. Like that, here also there will be a new term called center of charge. Yes, for the second distributed charge, there is a center of charge. Here, you should take R, the distance between centers of charges. Centers of charges. Yes, that is R. It is not simply the distance between the center of the particles. It is the distance between center of the charges. So please remember, hereafter Coulomb's law is valid only for point charges, not for distributed charges. Once again, Coulomb's law is valid only for point charges, not for distributed charges, because center of the charges will change. Always the distance between charges means the distance between center of the charges. Hope you understood well. We will discuss the remaining things in the coming modules. All the best for your preparation.